There's a bridge that's going to be repaired. $45 million, Army Corps of Engineers. This is the St. George's Bridge located in Delaware. It's needed repairs for some time, and now they're going forward on it. So here's some video imagery of it. And I'll pause and mention a few things. Let's look at the supports here. See, it's a little rocker there. There's two sides of the structure. Here, they're jointed at a seam. You can see the two sides, this side and that side. Cutting to the chase is that there's water damage coming across this tie beam. The loads are carried by the outside columns. This is a tie beam, gives it rigidity, stability at the upper end of this cantilevered beam, if you imagine it standing like this horizontally. So this gives you support in that direction. Helps with some torque and torsion also as the bridge gets vibrated by heavy traffic. These often can lock up. These guys can rust and lock up. I'm not saying these are rusted or locked up. I didn't really go dive deep in them. I was looking at the repair sections that they were calling out, and if they were addressing the paint damage here. I did not see it written on there. Let us look at it now. So let's take a little peek over there. And as we're peeking, you can see how it's drawn out, the repair size, 1 by 1, 1 foot by 1 foot. Pretty easy to understand there. As you look down here, you see again, this is the water damage from a section. Water damage from the midsection. So this bridge appears to have water that comes to the midsection, not ground left and right where the drains are, but appears to have drainage coming down the middle. And this is causing the efflorescence and swelling of the rebar by penetration through the concrete. Looking right here, we'll get closer to it as we come up. This will also remind you of the deck in the Royal Towers, part of the swelling and issues, like right here, for example, jumping right into it. Let's pause. That's that connection I told you that allows the bridge to flex, to move, if you will. This looks like a repair, right? At one time this was a repair. You can see the different colorations. You can see this spalled concrete that presents it look like it's impressed in, but in reality it's concrete that's flaked off, if you will. You can see the mapping showing right back through the repair. So they didn't go deep enough. They didn't do it secure enough to stop this mapping. And over here we have a significant looking shear fracture coming down, like it's overloading and shear fracturing on this outside of this column. Internally, this tie beam is able to resist the pressure of the outward force. And that would be, imagine this sitting in some sand and you're pushing this down. It pushes out this way and that way. Well, over here, the loads are, hey, they get to be taken up in part of this tie beam, the pressure, if you will. Over here, it's stirrups, total stirrups only, and not this counter pressure, if you will. And over here, there is no counter pressure. There's just stirrups wrapping it. So it looks like we have some strain here that's able to fracture or stress these stirrups out. I don't see water damage there. A lot of efflorescence, and it's continuous. It's on each one of these, continuing in the same issue. So when they rebuild this, will they address this that's doomed to happen again? Doomed meaning it will happen again. You see it also coming this way at the top surface of this, where it's not backed by this tie beam. The intention of the tie beam I already mentioned. So it's going to happen again. So they're putting $45 million into this, and unless they resolve this transfer of this load into the top of this column, then this will happen again. All right. What can be causing it? Well, the bridge does vibrate and shake a lot, and it's anchored at these points here, at where the anchors are. The anchors then transfer however deep their anchor's loading is into the concrete, and that pressure and rocking back and forth happens here, if not shearing and so you would take apart this bolt, you would look at it and see how much of a shear, how much deterioration took place to prove or disprove what I'm stating to you. If it is not the bolt, then it's simply the load on top of here. There's probably another plate below this, and that's rocking also. This whole cap is coming off right here, and then this is already lost plane. This is forward of us. This is where the column is supposed to be. This is where it's now, this outer part. So we got some rotation going on there to rotate this concrete. There's some, if you could take this apart, you'd see the stirrups have been torqued, twisted. It looks like they've been doing some steel work here, painting at one time. There was some lead removal done on this bridge back in the day, 2000, something like that. Again, there's spalling. You're looking at the sizing, and it looks like somebody's put their foot in it, right? But in reality, it's flaked off. We stop here, you start seeing, again, you're seeing a straight line. Now, this is not stress from overloading because there's no load on top of there. It would be compressive strength or tension on this beam, compression this side to that side or pulling away. That's not indicated here, and it's really not indicated here. This is more the surface concrete over these many years swelling. Because of reaction of rebar itself and concrete together, the marriage alone wants to fail. And here's some down here. But as you come over, you see again, looks like that. So like the Royal Towers, where you see all that mapping coming through. All right, so you can see that this is not deflected. It's this whole beam. It's not taking a load like that. And this is just again the mapping from the concrete. From the concrete and rebar reactions. This is where they're calling a repair out, and this is a 2x2 repair somewhere. I don't know where. This is 2x2. This is 6x4. So you tell me. There's a 1x1. There's a 2x2, and of course that can go much larger. They're just saying it's 2x2. At one point, it looks like they did attempt to stop to deal with water with this, I'm going to say silly band of paint. Instead of painting the entire structure to protect it from water, the exterior water, not the reactions that would still happen internally with the concrete itself, that they did this silly cap and called it a day. That's financials. Up here again, I don't know if this is locked or not, if it's moving properly. It's a very lightly loaded structure at this point. Here's your cap coming across that way, and we'll find more coming down and patterning this way. So we're getting consistent. We don't see the separation here, so it's not going north and south. Now it's locked in with the bridge. All right, so the bridge is indirectly acting as a tie also. Directly acting as a tie. Sorry about the indirect. This is acting as a tie also. And stabilization, like shear stabilization from it just falling over. And just showing the lights balling. And they're going to do a 1.5 foot by 2 foot section here. All right, and they're right at the bottom of where the reinforcement would be. So you tell me how that's going to work out. Where instead of taking it all the way down, they're going to come right about where the bottom of the reinforcement's probably located, and that's the cover. So they're going to create issues without totally encapsulating this with, say, a breathable paint. Now there's a fracture again. Excuse me. So you can see the old steel, the rusting that took place, and how it spalls it off. Spalls it off in a cone or 45-degree shape. As you can see what's next to come off. Oh, wait a minute. This concrete doesn't look like this concrete. Oh, so this was a repair somebody paid for at one time, and below and covering over and tapering off to this area here, they covered over what appears to be rusted steel, or you're ironically of all things that they cleaned this steel off, and now this steel is looking so great, or it's just right on the outside of their last measurement. It might have been over here, that they tapered off over here with this concrete. So this was exposed. They saw this and they didn't cover it. So the craftsmanship, you can see that this new repair goes right down to where this was exposed, and over to here. In fact, it goes over, and this is what you're getting, some capping of some rusted rebar without treating it correctly. Devil's advocate, that they just happened to stop right here. This was covered with this concrete here. They didn't see the spalled concrete, this rebar that was damaged, and they covered over it. I would need to see this a lot closer, but I'm already looking like it's tapered right down to it, so I'd find that pretty difficult not to see at that point, to expose it. So it looks like somebody did some covering of some existing, some damaged rebar. Presents that way, and then it could not. It could be I could just be coincidental, just that close. That's what the texture looks like. There's a chamfer. There's some exposed rebar. It's racing across. Stopping here, you see again, there's that midsection. This is where the water would come through. Same thing, everything's a duplication, one after another, because of the water issues. Right here, here, and over here. See the fracture again? Same thing, duplicating one section after another. There's your drains. There's your two sections of bridge sections meeting on this column. This looks tight here, and at the other intersection, the joint. And then we got this water coming down, and we have efflorescence starting to turn white, so it's continuous salts. And over here also, as you look there, it looks like they did do the painting there, but at the top there's an issue. Now this is 5 foot by 1.5 feet. That's cutting it tight. How do they handle that? All right, that looks weird measurements, doesn't it? Clearly this is where the rebar at the bottom is located, and this is the cover. This needs to come off. But 1.5 feet, so that looks like a cost overrun. Meaning they get to charge more once they expose it. They get to say, let's. You can see that we exposed that, and you owe us money. There it is, all the way down, all these sections. As you look up, right there, there's the rusted deck. This is where the intent of the water was to run off left and right at the downspouts, but clearly the water is pooling at this place here, making this a gutter, a downspout area. A gutter, this surface wall will be the downspout. Going across this steel, swelling it up over the years of salt water. This bridge gets treated with salt, landing down here, and then you're causing you problems. But this is a clear point of a low point, becomes a downspout. And again, that's not the intent of the structure, to be a downspout here. Why is the water pooling there on each one of these? Well, clearly this bridge has some deflection, and this steel that's directing it that way, or it was built that way. Or the covering layer of concrete and asphalt over the years, they pitched it towards the damn middle of that part of the structure by repeated mistake. Right there. Now you can see this one doesn't have a tie. Let's see if I go back down. And I'm just looking up at the underside of it. That's the water that goes around. Rusted steel. You can see the layer of the stirrups right there. The depth of it. So that's your stirrups of this beam. And straight above is the swelling of the steel and from the water. And there's the gutter, I'll call it. This is added to strengthen the bottom, like a tension piece, to so it can take more load and tension. But there looks like it's failing in a few points. Looks like I can't quite tell. I didn't get back up there with a close enough look, but looks like some bolts have fallen off. Failed 100%. And we look down to the left rather. And that's again the condition of the steel. Over time, the steel and the concrete just doesn't work out. That's just, marriage is doomed to fail. But now they're going to put $45 million into it to try to save this marriage. But the man part of the steel, I call it, the structure rather, the steel, and the woman's the concrete. The man part is bailed. This is a failed system. Okay. Again, there's no tie on this one. You see this one? There's no tie going across, and we see a failure, that bursting over here. See the painted cap? So when look back in time, you know when this was painted. You see that this is missing paint, and you can determine that between X time and the time and now, this failed. So it's got some lateral movement, perhaps. Again, no tie there. The span then takes the tie there. But these distribute the load down, so it's just less of a span by putting it roughly mid-span. As we slip out here, we see all the rust on the outside of the structure, all of this acting as water flow from railings, etc., and this all of it acting as a gutter. They're the two separate bridge decks. Let's call this a bridge deck here and bridge deck here. Again, you see some more steel at the bottom, tying them together, making it this gusset web system act as one gusset web. And so you see there's a cantilever part of this bridge. This is for pedestrians or bicyclists. Noteworthy, some of them are extra braced, every other one, and like this one, and then every other one is braced. These are not braced, and in fact they tie it it's got a cutout. Not everywhere, like right there. All right, let me just adjust real quick. Okay, again, looking at the efflorescence, there's some paint there. But we're back to the column again, that column behavior and the connection with the supports. There's that fracture coming all the way down like that. This fracture is not coincidental. It's not water in it. I mean, now it might be water, but this is based off of this load. And then we have this fracture crossed here. It's probably based off of this anchors they used, the anchors themselves swelling up and creating this new shear plane. It's like doing a wedge in a stone. How you break wedges in a stone? How you break stone? You drill a hole, put a wedge in there, drive something between the wedge. It separates and blows and breaks apart the stone. These are the same thing. The concrete. These are built-in internal wedges. The steel is. In this case, this is an external wedge, if you will. Rots, swells, and expands, and causes this failure, this fracture line. If there was another one here and here, it would have continued over fully. These are no exceptions. The anchor bolts. All right, so they're calling for 3 foot by, I don't know what that is. Oh, 1.5 feet. That's a point, decimal. So they're just going to piece this together instead of just saying replace the head. Scab it. Piece it together. This is, not the right idea. It's more troublesome than not. All right, again, here's your tie. So you see these. You don't think of it as deflection. It's not loading. It's not loading on top of there. It does load back here, but not on these. Again, you're going to see the duplication. Here's a repair. How it lasted, it shows you that it doesn't last. This has failed already. And let's take a look at it. We'll go about another 3 minutes into the video, not the full video. And I'm just discussing it with you. Again, there's 2 sections of bridges together, and it's got a little gutter system up there. This has got a lot of water that's now eroded the concrete, smoothed it over time. The salt water. Remember, this bridge gets iced, salted, and we can see a little bit of that steel at the top one moment. But this again is your efflorescence. This is that paint job. That's probably pigeon poo. and some other things. But it looks pretty good. Looking at this fracture real good there, it's not opening, it's tight. Looking at whatever that might be. And there's your swelling again. And there's your beam is rusted out here. It's starting these plates that tie in down here. This one looks like it's rusted out. This becomes a gutter, and it's not good. A downspout and gutter, and then it's all the way down, as you can see a moment ago. All the way down, but only at the ends. So you see, you don't see it here. You see it right where it happens to line up with the tie beams, and these are intent also, I believe, of it's like a shear brace to stop it from just falling over into that shed. Now we're back to this column again, and there we go. And there's a repair. There's a repair again, right here, and if that's the repair. It looks like junk, doesn't it? It's not really jacketing, not really the top-notch job, I can say that much. Now here again, duplication. There's that steel that's been some of it's cut away like that, and some of it's like this. This is a bridge decking, the B decking. This is what I proposed for that Royal Towers. It would be the same thing, supported out there and like this. I did think about bracing back to the wall. It's just not worth it. The loads are too great. It might cause a rotation into the structure. It wasn't designed to take that torque rotation that we're pushing in. As you can see here, this fracture's all the way down. This is just flaking off, and this is fracturing down. And this was a repair at one point. Probably down to there. We have some look down the side of here. Just looking down the side, got your efflorescence. Here's your downspout. Looking back to here, you can see the correct quality of the repair. And did it work? Did it work as intended? Well, you still got this fracture, and they never closed it up with paint, Sikaflex, or anything. They just put it over, and that was it. It's clearly swelled and fractured and duplicated itself. Just duplicated itself. So why put the money into these repairs like this if the repair will just duplicate itself? It's not resolving the problem. There's the extra. There's the plate, one plate there, and your secondary plate. It looks like right here. Okay, I'm just trying to get a better shot of it to confirm it's a plate or steel. It looks like, great. It looks like concrete. So here's your plate. Plate and plate. See? Plate, plate. And your concrete capping is now missing. This might be where your stirrup goes. So there's your lower plate. Here is the roller system. I said they lock up. I can't tell how this one's doing. I didn't bother looking at it. It's different exposure, so I can determine what I was looking at. Then I could see that it was concrete. Okay. Said I'm losing some video frames, so give it a second. There we go. Let me see if that does it. So here we have, again, acting like a gutter everywhere. And here's a gutter here, that comes right down. I've seen this duplicated on this structure in a few places now. The outside, here, and here's a downspout. The intended gutter is here. So are we looking at clogged gutters? And back here again, you've got mid-span support. But here they're just doing the structure that way. Again, the gutter issue, here's a 3x2 repair, just to give you guys a general idea what you're looking at. If you're going to look, if you see stuff like this, you can see that water saturation, the salts and all, how he textured it. And video frames, thank you. Yeah, it's a good shot. There's a good shot of the roller, the pins that allow the rock back and forth to your control joint. So hopefully you can enjoy that. That's about the size of it. Going to end the video. So here's obviously all of this is your water issue. From here over to here, a lot of salts. And take care, guys. Love you. And how do I end this video? There we go. Take care. Bye.